So we're going to look at two application problems just to get us ready for the work we're going to do tomorrow with application problems. So this rational expression is 130 times x divided by 100 minus x. Now, this represents or describes cost in millions of dollars to inoculate a percent of the population against a particular strain of flu. And what we have here is a couple things that it wants us to do. First of all, it wants us to take a look at some situations, say, where you try to inoculate 40% of the population, 80% and 90%. So when we do that, for the first one, when x equals 40, we basically have 130 times 40. And all we're doing is we're evaluating 100 minus 40. And what we'll get is 5,200 over 60. And that's going to give us 86.6, repeating. But remember, that's in millions of dollars. And then you can do x equals 80, and then x equals 90. Pause it and complete those evaluations. If you completed those evaluations, you should come up with 520, and that's a million. And then 1170, and that's really $1,170,000,000. So as they try to inoculate more and more of the percentage of people, it ends up costing more money, as we can see. So that's part A. But that's what we want to be able to see from just plugging in some numbers. 40%, 80%, 90%. In part B, this is a pretty straightforward question. For what value of x is the expression undefined? Well, you know that 100 minus x, to get that to equal 0, and that's just by looking at it, we know that when x equals 100, it's undefined. It also means as we get closer to 100%, this cost is going to skyrocket, and it's already climbing big time as we went from 80 to 90%. Just imagine what it will go to 95%, or even trying to get close to 100% of the population. So our interpretation of part C, what happens to the cost as x approaches 100%. So as we see, this cost is going up higher and higher, but between just 80 and 90%, it more than doubled. So if we get closer to 100%, it's just going to be impossible as far as the cost goes. So the conclusion really is it's impossible to inoculate 100% of the population because of the cost. That's a tough pill to swallow. All right, let's take a look at 92. So we're going to look at this problem, and basically it says the average rate of a round trip commute having a one-way distance d is given by the complex rational expression that you see on the left. R1 and R2 are the average rates on the outgoing and return trips respectively. So respectively just means that R1 is outgoing and R2 is the return trip. You want to simplify the expression, then find your average rate if you drive to campus averaging 40 miles per hour and return home on the same route averaging 30 miles per hour. So we know that this return home is R1 and this should be R2 when we get there. And it says explain why the answer is not 35 miles per hour. All right, so let's start by trying to simplify this expression. So we have 2d all over d over r1 plus d over r sub 2. Now if you remember from previous videos and previous work, what we can do is we can worry about the denominator. If I take d over r sub 1 plus r sub 2, and just remember, how do I add fractions? Well, they have to have a common denominator. So if I take this and I multiply this guy by R2 and this one by R1, then we're going to get, I'll make sure I have that over 1. We always want to have a form of 1. So we're multiplying by a form of 1, so it's not going to disrupt any of the equivalents. that's going on. So let's do that. 2d all over, and maybe you can do it quicker than I can. dr sub 2 plus, we have a dr sub 1 on the top. And on the bottom, we have r sub 1 times r sub 2. Well, this is actually nice because we can say 2d all over. And I'm just going to group these. I can do r1 plus r2 in parentheses. That's all over r1, r2. Now, I'm going to bring the Yankees back. 2d divided by all of this. And this is just my little thing for remembering. I don't like fractions, so I always use this New York Yankee thing. No, I'm not going to change the first term. Yes, I'm going to change that to multiplication. Yes, I'm going to do the reciprocal. r1, r2. And we have all over d, r sub 1 plus r sub 2. That simplifies here. R sub 1, R sub 2. Lots of multiplication going on the top. Now pay close attention and you'll see that you have a little bit that factors out. That's 1. So our expression looks like this, and we don't have to worry about distance. We just have it in terms of r1 and r2. So now I take r1 and r2, that's 40 miles per hour, and then 30 miles per hour, that's a 0. And what we're going to end up doing is just evaluating. So when we take that, we have 2 times 40 times 30 all over r1 and r2, and that's 40 plus 30. When that's evaluated and all said and done, you can do that in a calculator, 34.28 miles per hour. That is not 35. And you'd want to explain that in terms of why you know that it's not going to be 35 because of the mathematics involved in those expressions. So those are a couple applications. Those should provide you with a little bit of knowledge and interpretation of the ones that we're going to practice in class tomorrow.